Hello everyone. In last video, we have discussed about the first part of electrochemistry, and in this video, we will discuss about second part of electrochemistry that will contains batteries and corrosion. So, let's start.
Batteries. Batteries are the most important practical application of galvanic cells because batteries are very useful in day-to-day life. Batteries can be classified into two categories: single cell batteries or multi-cell batteries. Single cell batteries consist of one galvanic cell only, and multi-cell batteries consist of several galvanic cells linked in a series to obtain the desired voltage. For obtaining high voltage, we can use multi-cell batteries. Primarily, batteries can be classified into two main categories: primary battery and secondary batteries. Primary batteries, the batteries, though after use they cannot reuse again, and the secondary batteries they can reuse again and again. The most important example of primary battery is dry cell, and the important example of secondary battery is lead storage battery. Here, a typical example of lead storage battery. Here, 12-volt battery consists of 6 individual cells connected in a series, and the overall cell reaction can be divided into two half cells: anodic half cell reaction and cathodic half cell reaction. At anode, lead grade packed with spongy lead, Pb, lead reacts with sulfuric acid to give lead sulfate and hydrogen ions with the releasing of 2 electrons. It means here lead oxidized into lead sulfate by giving 2 electrons. At cathode, lead grade packed with lead oxide. Lead oxide reacts with sulfuric acid and gain of 2 electrons. By gaining of 2 electrons, lead oxide converted into lead sulfate plus H2 water molecule. At cathode, here adding of 2 electron or gaining of 2 electrons is called reduction. So at anode, oxidation will take place, and at cathode, reduction will take place. Here electrolytes are 38% of sulfuric acid, and what are the cell potentials of lead storage battery? 1.924 cell potential is desired from lead storage batteries. Then dry cell is a primary battery, also called a Lake-Lanze shell, uses in viscous paste rather than a liquid solution. Hence, here again reaction can classify into two categories: anodic reaction and cathodic reaction. At anodic reaction, zinc converted into zinc ions by giving 2 electrons, and cathode, manganese dioxide and carbon black paste on graphite. Manganese dioxide reacts with ammonium molecules by gaining of 2 electrons to give manganese trioxide plus ammonia molecule. Here The important electrolytes are ammonium chloride and zinc chloride paste. And the cell potential of primary battery or zinc dry cell is 1.5 volt, but deteriorates to 0.8 volt with use. Now, second example of primary battery is alkaline dry cell. Alkaline dry cell is a modified Lagrange cell which replaces ammonium chloride with sodium hydroxide or KOH. Ammonium chloride replaced by the help of NaOH and KOH. Here again reactions at each electrode can be seen by the following manner: zinc plus 2OH minus to give zinc oxide plus water molecule and 2 electrons. Hence oxidation will take place at anode. At cathode, manganese dioxide and carbon black paste on graphite. The reaction is given by this manner. Electrolytes are used as NaOH, KOH and zinc hydroxide paste. Here cell potential is 1.5 volt, but longer lasting, higher power and more stable current and voltage. It means alkaline dry cell is more beneficiary as compared to zinc dry cell. Next example is mercury dry cell. Mercury dry cell is another example of primary batteries which is modified Lagrange cell which replace manganese dioxide with mercury oxide and uses a steel cathode. Here again anodic and cathodic reactions can be represented by these two half cell reactions. And here electrolytes are KOH and zinc hydroxide paste. Here cell potential is 1.3 volt with small size, longer lasting and stable current and voltage. So mercury dry cell can be used. Next important battery is nickel cadmium battery. Another modified Lagrange cell which is rechargeable. This is the rechargeable battery. Anode and cathodic reactions can be represented by these two reactions in the form of these two reactions. In this cathodic reaction, nickel third compound, nickel oxyhydroxide, reacts with the water molecule with the gaining of electrons to give nickel hydroxide plus hydroxide ion. Here important electrolytes are nickel oxyhydroxide and NiOH. Cell potential is 1.30 volt. This is the most important battery, lithium ion battery, the newest rechargeable battery. The newest rechargeable battery is based on the migration of lithium ions. Lithium ion can migrate from one place to another place by the help of a medium. Here again complete cell reaction is divided into two half cells, anode half cell reaction and cathode half cell reaction, or it may be a oxidation half cell reaction or a reduction half cell reaction. At anode, oxidation will take place and lithium metal converted into lithium ion by giving or releasing electrons. At cathode, metal oxide or manganese dioxide converted into lithium manganese dioxide by the accepting lithium ions. Here the cell potential is 3.0 volt. It is the greatest cell potential of the batteries. Electrolytes are lithium containing salts such as lithium chlorate in organic solvents. Solid state polymers can also be used. Fuel cell. Fuel cell uses externally fed methane or hydrogen which react to form water. Most common is hydrogen. Anode or cathodic reaction can be represented by the following manner. Cathodic reaction, porous carbon containing metallic catalyst. Porous carbon, that oxygen gain of 4 electrons to give 4 hydroxide ions. Here electrolytes are hot aqueous KOH solution and cell potential is 1.23 volt, but is only 40% of the cell capacity. Next and last topic of the part second of the electrochemistry is corrosion. Corrosion is the oxidative deterioration of metal. 25% of steel produced in USA goes to replace steel structures and products destroyed by corrosion. Rusting of iron requires the presence of both oxygen and water. It means rusting of iron requires the presence of both oxygen and water. It means here, in the absence of water or oxygen, rusting or corrosion will not occur. Rusting results from tiny galvanic cells formed by the water droplets. Rusting or corrosion, suppose this is the best diagrammatically representation of corrosion. This is the iron metal rod. Here iron metal rod is made up of iron atoms. These iron atoms converted into iron 2 plus ions, Fe 2 plus ions, by giving 2 electrons or by releasing 2 electrons. These Fe2 plus ions again release 1 electron and get converted into Fe3 plus ion. These Fe3 plus ions or Fe2 plus ion reacts with oxygen from air and give 2H2O, water molecule. It means here brown colored substance is called rust. Rust is formed with the help of water droplets and oxygen and iron. The formula of rusting is Fe2O3 dot XH2O. XH2O means X is number of water molecules. Here complete cell reaction can be divided into two categories, two half cell reactions. As we know that oxidation half cell reaction and reduction half cell reaction. And overall, while we will write overall reaction, we will add both reactions. Fe solid plus O2 plus 4H to give 2Fe 2 plus H2 2H2. Hence 2 electrons and 4 electrons, these are cancelled by each other, 2 electron and 4 electrons. It means Fe is multiplied by oxidation half cell reaction is multiplied by 2. So Fe 2F converted into 2Fe plus O2 plus 4H to give 2Fe2 plus 2H2. This is the complete structure of corrosion. Now, prevention of corrosion or rusting of iron. Galvanizing. Galvanizing is the coating of iron with zinc. Zinc is more easily oxidized than iron, which protects and reverse oxidation of the iron. Cathodic protection. Cathodic protection is the protection of a metal from corrosion by connecting it to a metal. Which metal? A metal which is sacrificial anode that is more easily oxidized. All that is required is an electrical connection to the sacrificial anode, usually magnesium or zinc. So that's all for second part of the electrochemistry. Assignment will be assigned later separately. Thank you.